before you can solve absolute value equations or inequalities, you have to understand the definition of absolute value. And so we define the absolute value of a number a, whether a is greater than 0 or less than 0. So that's your first consideration is whether the value inside the absolute value symbols is greater than or equal to 0 or less than 0. Because you calculate the absolute value of a in the following way. If a is greater than 0, that means a is to the right of 0, then the absolute value of a is just the distance between 0 and a, and that's a. So if a is greater than 0, the absolute value of a is equal to a. But if a is less than 0, that means that a is to the left of 0 on the number line, then the absolute value of a can't equal a because a is less than 0. Absolute value must be a positive number. It's a distance. We need a number that's this same distance away from 0, and of course that number is on the other side of 0, same distance away, but it's not a, it's the opposite of a. And so the absolute value of a is equal to the opposite of a if a is less than 0, because in that case the opposite of a will be greater than 0. Well, after you understand absolute value as the distance between 0 and a number a, you can work with the absolute value as the distance between a and any other number x on the real number line. So an interpretation of absolute value geometrically is that it's the distance between x and a on the real number line. And so this definition is just the special case when a is equal to 0. Okay, so how do we interpret this geometrically? Well, if you have, again, a fixed number a, and then you want to look at x, so suppose x is to the right side of a, then the distance between x and a is x minus a, because x is greater than a, and x minus a will be positive, and so x minus a will tell you the length of this segment. On the other hand, if x is to the left of a, then a is greater than x, and so the distance between x and a would be calculated by doing a minus x. And again, that'll give you the same length, the same segment length. But these two numbers, x minus a and a minus x, are opposites. And so that means they have the same absolute value. And that absolute value is the distance between a and x. And so that's why the absolute value of x minus a is the distance between x and a on the real number line. The final thing you need to understand about absolute value is how to convert an absolute value equation and remove the absolute value symbols. So we have this type of equation, which is a sort of standard form. If you have an absolute value of an expression or a quantity is equal to c, is equivalent to means the same thing as x is equal to plus or minus c. And so that's, remember, just two equations, either x is equal to c or x is equal to the opposite of c. So those are the two equations that you would solve in order to solve an absolute value equality of this type. And the connecting word there is or. X can be one or the other. It cannot be both of those at the same time. So we'll use that definition to solve this equation. 4x plus 7 in absolute value is equal to 9. Well, that means that numbers that have absolute value 9 are either 9 or negative 9. So 4x plus 7 either equals 9 or it equals negative 9. And notice we remove the absolute value symbols and write 4x plus 7 equals 9, connecting word or, 4x plus 7 equals negative 9. And these are two equations that you can solve on your own. They're very simple to solve. And you'll get two isolated values for x. And you can plot those as points, little dots, on the number line. Okay, this next equation is just not in standard form. So let's do that. So we first have to subtract 6. So we'll have 3 times the absolute value of x plus 5 is equal to 9. And then we divide by 3. So we get the absolute value of x plus 5 is equal to 3. And so now it's in the standard form, and it's just like this problem over here, so I'll just let you work that one and finish that off. Okay, this leads us to the bigger topic in this section, and that is absolute value inequalities. So an absolute value inequality is something like this. Suppose you want to know what are the numbers that satisfy absolute value is less than 3. Well, if the absolute value of a number is less than 3, that means if this is where 0 is and this is where 3 is, then all these numbers have absolute value less than 3. But also, if you go out to negative 3, all of these numbers have absolute value less than 3. And so this inequality can be rewritten without absolute value symbols by saying that x is between, and remember for between we use two less than symbols, x is between negative 3 and positive 3. And our solution then would be written in interval notation as open interval negative 3 to 3, just like that. So we'll use this idea to solve this inequality, which instead of having x inside the absolute value symbols, it has x minus 5. Well, that doesn't matter because the drawing is the same. We have 0, and we have 3, and we have negative 3. And this time we're going to include the endpoints because we have less than or equal to 3. So we want numbers with absolute value equal to 3, which are these two, or less than 3, which means between those two. And so this time our inequality is going to contain in the center x minus 5. That's what's between 3 or equal to and or equal to negative 3. So now if we add 5 throughout this inequality, we get 5 minus 3 is 2 is less than or equal to x is less than or equal to 8. And so our solution interval is the closed interval from 2 to 8. Okay, so now the next inequality doesn't use a less than symbol. It uses a greater than or equal to symbol. So let's see how that will be interpreted. We'll start off by drawing a line, and the number we want to compare to in absolute value is the number 2. So we look at where 2 and negative 2 lie. Now we want the numbers that have absolute value greater than or equal to. So we know we're going to include the endpoints. But this time, instead of being between negative 2 and 2, we want the absolute value to be greater than 2. So we actually have to be greater than 2 or, on the other hand, less than negative 2. And so this time, we get two separate inequalities joined by the word or, because you can't be in both of those places at the same time. You can only be in one or the other. And so this time, when we remove the absolute value symbols, we get from this one, x plus 5 is less than or equal to negative 2, or from this one, x plus 5 is greater than or equal to 2. And now we'll solve these two inequalities. So we get x is less than or equal to negative 7, or x is greater than or equal to 3. So all the numbers less than or equal to negative 7 means that we want to include negative 7 and go to the left, but we're never going to find the end of that. That's to minus infinity. And or means a union. X is greater than or equal, oh, it should be negative 3. X is greater than or equal to negative 3. So we start at negative 3 and we go to the right, and we close with an open interval on the right side. So that's the solution interval for that one. The laminate problem is another one of these geometric interpretations of absolute value. So the tolerance of this laminate is 0.003 inches. So that means we want the distance between what the number that we want is and the true thickness, which we don't know because of the tolerance. We want that distance to be less than 0.003. So the distance is 0.20 minus x in absolute value has to be less than 0.003. There's your interpretation of this as distance, and then I'll leave it to you to solve that inequality.